All right, let's dive into a substance that's so common we barely even think about it. And yet, it's so strange it seems to break some of the most fundamental rules of chemistry. Today, we're going to uncover the hidden science of water. So let's start with the really big picture. You look at our planet and it is just covered in water, right? But here's the catch. A whopping 97% of it is salt water. That leaves this tiny, tiny sliver, just 3% as fresh water. And most of that is locked up in glaciers. This scarcity is a huge part of water's story here on Earth. Now get this, at any given moment, only 1,000th of 1% of all the water on Earth is actually in the atmosphere. It's practically nothing. So how on earth can such a tiny fraction have enough power to create all of our planet's weather and climate?
Well, the answer is that it's always moving. And I mean always. It's a constant, powerful cycle. You can think of it as the planet's massive, endlessly circulating plumbing system.
It's really this incredible four-stage journey. First up, you've got evaporation. The sun's energy hits the water and turns it into vapor, which then rises up into the air. Then you get condensation. That vapor gets high up, it cools down, and it forms clouds. Next, of course, is precipitation. The water falls back down as rain, snow, you name it. And finally, collection. It all gathers back in the oceans, lakes, and rivers, ready to start the whole trip all over again. And here's the really wild part. This whole cycle is in perfect balance. The amount of rain that falls on land is pretty much perfectly matched by the amount of water evaporating from the oceans. It's why sea levels don't just drop. This even includes the water that plants breathe out in a process called evapotranspiration. It's just this beautiful, self-regulating machine. Okay, so that's the what. We know what happens, but that doesn't explain why. Why is water so special? To get that, we have to look at its peculiar powers, all the ways it seems to just break the normal rules of science. There are really four big mysteries about water. First, it's the only natural substance we find as a liquid in these huge quantities on Earth. Second, it flips between being a solid, a liquid, and a gas so easily. Third, and this is a really weird one, its solid form ice actually floats. Almost nothing else does that. And finally, it can absorb a massive amount of heat without its own temperature changing very much. So what is going on here? Well, the answer to all these bizarre properties isn't in the big grand water cycle. To find it, we have to zoom way in, all the way down to the molecular level. We're about to unlock the secret of something called the hydrogen bond. So, what is it? What single force could possibly be responsible for all of water's strange and wonderful powers?
It's this, the hydrogen bond. It's a special kind of attractive force. You can think of it like a tiny, weak magnet that pulls one water molecule towards the next. This one, seemingly simple attraction is the key to, well, pretty much everything.
So how do these little magnets work? Is because a water molecule is what we call polar. Here's the simple version. The oxygen end of the molecule has a slight negative charge, while the two hydrogen ends have a slight positive charge. And you know the rule, opposites attract. So the positive hydrogen on one molecule sticks to the negative oxygen on another. That's it. That's the hydrogen bond. And this has enormous real-world consequences. Take floating ice. When water freezes, those hydrogen bonds lock all the molecules into this rigid, open, hexagonal pattern. You can see all that empty space in the structure. This makes ice less dense than liquid water, which is why it floats. And that creates this incredible insulating layer on lakes in the winter, protecting all the life swimming around underneath. But these bonds do way more than just affect density. They're also the reason water can store and release absolutely massive amounts of energy, a power that we call latent heat. Latent heat is basically hidden energy. Think about it. When you add heat to a block of ice, you'd expect its temperature to go up, right? Well, it doesn't, not at first. Instead, all that initial energy is used just to break the hydrogen bonds and melt the ice into a liquid. That energy gets hidden inside the water. And we can put a number on it. It takes 80 calories of energy to melt just a single gram of ice. All of that energy is just going into breaking those bonds. But believe it or not, that's just the warm-up act. Now look at this. To turn that same gram of liquid water into vapor, it takes a staggering 540 calories. That is a huge amount of energy getting stored in water vapor, which then gets carried by winds all around the globe. This is literally the engine of the water cycle. It's like a global thermostat, moving heat from the equator to the poles and regulating our entire climate. You've actually felt this in action. When you get out of a swimming pool, you instantly feel cooled, right? That's because the water on your skin is evaporating, and the energy it needs to do that, that latent heat, is being pulled directly from your body. Evaporation is fundamentally a cooling process.
Okay, now for one final piece of water magic. This is a little trick that happens right inside your own freezer. I call it the case of the vanishing ice cube.
This involves two processes you might not hear about every day. First is sublimation. That's when a solid, like ice, turns directly into a gas. Poof! It just skips the whole melting phase. Deposition is the exact opposite, when a gas turns directly into a solid, like when you see frost form on a cold window.
And this brings us to a very common household mystery. You've definitely seen it on that package of food that's been in the back of the freezer for too long. What in the world is freezer burn?
Well, it's not a burn at all. It's actually sublimation. The very dry air inside a frost-free freezer literally pulls the frozen water crystals directly out of the food. They go straight from solid ice to invisible vapor and just drift away. The food isn't burned, it's just drying out. Mystery solved.
So just think about the journey we've been on. We started with a tiny, slightly magnetic molecule. That magnetism creates the hydrogen bond. That bond is the reason ice floats, which protects entire ecosystems. And that same bond is what creates latent heat, the hidden energy that fuels our planet's entire climate. Isn't it just amazing how the very smallest things can have the absolute biggest impact?